putting together information in multiple rows is called aggregation. So far, SQL expressions just referred to values in a single row at a time. We'd process each row using the expressions in the SQL statement, and we'd generate a row from each. But it turns out that you can put aggregate functions inside the columns region of the select statement, and that computes a value for a group of rows. By default, the group is all rows, and so if you have a table, like this example table here of kinds of animals, with the number of legs they have and the typical weight that they have, then applying an aggregate function like max to the legs column of the animals table will take a max over all these values, and the biggest number there is 4. But what's interesting is that even though there were 6 rows in the input, we have only 1 row in the output. So that's the key property of aggregate functions, is that they change the output to have only 1 row. There are some other aggregate functions. Let's take a look. In addition to max, there's min. There's also sum and average. Select sum weight from animals will give us 1 row. That's the sum of all the weight values. Select max of some expression, like legs minus weight, will give us 1 value, where for each row we computed the legs minus weight value and then found the largest possible result. That came from the parrot, which has 2 legs and 6 weight. It didn't pull together information from different rows. Like it didn't subtract 6 from 4, because instead it just looked 1 row at a time and computed this result, and then took the max over all the rows of that result. So if you ever want to see the steps, you could compute legs minus weight first, and then you see what we're taking the max over. But if you wanted to compare the maximum legs and the minimum weight, you could do that with an expression that contains 2 different aggregate functions. And these maximum legs came from the ferret or dog or cat row, where this minimum weight came from the parrot row. So these don't have to come from the same row. Instead, they're 2 separate aggregations. We can subtract one from the other, or we could list them out as 2 separate columns. Both ways are fine. One thing you don't want to do is have an expression that has an aggregate function, but then has a column that's not aggregated at all. Because you get a result in SQLite, but in other SQL database systems, you're going to get an error. And you just shouldn't do it because it doesn't really make sense. You want 1 row, so you want the max legs. I know what that is. But then you say, I want the weight. The weight of what? We had 4 different weight values here, and we didn't say how to aggregate them. And so, yeah, it gave us 1, but it doesn't tell us which one it was or why. And so that's not something that you want to do. Either perform aggregation for all the columns or don't. If you don't, that's fine. You'll end up with 6 rows in the output. But if you're going to aggregate, you should aggregate them all. So here we'll get the max legs. And let's try out average. The average weight is 2,000. Why so big? It's because of that T-Rex. Here's another averaging example. What's the average rating over all the votes in the IMDb dataset? In the ratings table, there are 1,000 different rows, 1 per movie. And each of those rows shows you the average rating for that movie and the number of votes that that movie received, where the votes are each rating. Well, it turns out that you can't just average the average ratings, because different movies got different numbers of votes. And for example, if in 2 movies, the first one had 80 votes and an average rating of 7, but the second one had fewer, only 20 votes, and an average rating of 9, then the average rating was not the average of 7 and 9, which would be 8. Instead, it's closer to 7 because there were many more votes of 7 than there were votes of 9. And here's how you compute it. You got 80 votes of 7, 20 votes of 9, and 100 votes in total. Gives you an average of 7.4. So for this data set that has 1,000 rows, one per movie, with an average rating for that movie, that's the average of all these 143,615 votes. How do you get the average across all the votes? I'll let you think about it. Then we'll look at the answer in 3, 2, 1. There it is. For each row, you multiply the average rating by the number of votes to get the total rating for that movie. Summing up the total ratings for each movie gives us the total ratings. Dividing by the number of ratings gives us the average rating. In this data set, it was 8. That's not just because of rating inflation. That's because we chose 1,000 highly rated movies to make this data set in the first place.